No.
No, it doesn't have.
Nick and I are aerospace engineering graduates of CU Boulder. We decided to make an RC airplane in between looking for jobs and continuing our education, meeting on Discord because we were in different countries. The plane must be capable of 220 miles per hour and a 95-minute flight time at a cruise speed of 50 miles per hour. We tried to make the design space like in the industry, but it wasn't accurate at all at RC scales, but we had already built 4 prototypes by the time we realized. Anyway, we decided to just use Raymer's drag polar prediction method to perform our own analyses. We couldn't decide between a delta wing or a conventional hotliner configuration, but the delta was conceptually and mechanically simple and had less CD knock, so we went with that. These thrust required curves show that the delta configuration has less drag at cruise and max speed than a hotliner configuration with the same wing area. We could have reduced the hotliner wing area because it was more efficient at higher CLs, but then that would have unacceptably raised our stall speed. Anyway, we decided on a tailless delta with a 13.5-inch wingspan. We had actually started out with a pusher configuration with a heavy and complex assembly of 3D printed parts, but we came to our senses and printed a much simpler structure that was base mode friendly to save weight and print time. We printed the parts, assembled them with carbon fiber spars, and finished the first prototype with a 4S battery and a 6x4 prop.
Wow.
We thought the yaw moment was being generated by the prop swirl hitting the vertical fin, so we made a foamboard prototype with winglets, but that didn't fly either, so we doubled the wingspan to 27 inches to reduce wing loading and better control torque roll. We stuck to the 6x4 prop and decided to make the plane from foamboard from now on because it was quick and simple to build.
This is our first working prototype between me and ShawNic. There's a wing cube loading of 6, so it's roughly easy to fly airplane. And it's got decent power.
Oh. We reduced the wingspan to 19 inches because the oversized wing was flying so well with no P-factor or torque roll at around 120 miles per hour before it folded in half. We added a foamboard shroud for strength and drag reduction along with a keel and a carbon fiber spar. We used a 4.75 by 4.75 prop because we realized that torque roll becomes uncontrollable if the prop diameter exceeds 1/4 of the wingspan. It flew like crap. There was a lot of P-factor. So we tilted the motor around 7 degrees to the right, which is a solution we should have adopted sooner. This solved all our handling issues.
God, it's not like a turd anymore.
Then we kinda ran out of money, so after a few weeks of scraping together some funds, we used a 6S battery to get the plane up to around 150 miles per hour. These are approximate figures because we cannot yet afford a flight controller or other equipment to accurately measure our speed. Stay tuned for part 2 where we refine the configuration and attempt to reach our target speed.